Hello everyone. In today's lecture, we will look at very important concepts in networking, that is TCP congestion and congestion control mechanism. This concept explains how TCP prevents the network from becoming overloaded and ensures smooth communication. So let's first see what is congestion. Congestion occurs when a network has to send too many packets, okay, and the network cannot handle that load. Okay, so congestion occurs in a network when too many packets are present and network cannot handle the load, and this leads to issues like packet delay, packet loss, retransmission, and reduced performance. You can think this thing like a traffic jams on a busy roads. If too many cars enter the road at the same time, the entire system slows down, right? Similarly, when too much data enters the network, congestion happens. So to avoid this congestion, TCP uses something called congestion control mechanism. Okay, congestion control mechanism. So we are going to see what is those congestion control mechanism. Fine. Now to understand about the congestion, let's take this particular scenario. Okay, here we consider this is as a sender, a receiver. Okay, and what I'm doing is I'm pulling out all the routers in this world and I'm putting together, and when the sender wants to send this packet, this packet will travel to all these routers somehow. Okay, and consider it will reach to receiver. Fine. Now we all know that sender has something called a buffer. Okay, and receiver also has something called buffer, right? Both the parties have something called buffer, and here also receiver has something called buffer. Now sender wants to send a packet. When sender wants to send a packet, how sender will decide what would be my buffer size? What would be my buffer size? How sender will decide? See, like data link layer, even in transport layer there is something called flow control. Hope you remember all this thing, right? So what flow control mechanism says that sender should send a packet when a receiver is in the situation of accepting the packet. Okay, if receiver is too busy, or if the size of the buffer, whatever the buffer receiver has, it's not vacant, it's not empty, then still receiver, whatever the packet sender sends, receiver will discard it. Okay, the sender should not send the packet when the receiver is too busy or it is not in the state of accepting the packet. Okay, the sender should control those things. Okay, if for example this receiver, for example receiver has a capability of accepting 1 GB packet at a time, then sender should not send 2 GB file. It also should restrict of sending only restrict of sending only 1 GB. Fine. So if a buffer size of a receiver is 1 GB, sender should also send 1 GB. It should not send 2 GB file. Fine. So that is the condition. So if the sender sends 2 GB file, definitely sender don't have that buffer to store that much amount of packet, right? So he will discard that packet. So this situation should not happen. So we have to take control of those situations. That is what this flow control mechanism does. Okay, or if the receiver is too busy in consuming that packet, at that time also, if your data rate is too high, you keep on sending the packet. Sender is keep on sending the packet and receiver is not in the state of receiving and consuming that packet. He is busy in processing the packet. Still he will reject the packet. So those controls should be maintained. He should, so that control will be maintained at the sender side only. If sender side, if we somehow restrict the sender to send those many packets, okay, and the amount of packet what sender should send, if we have that control, then definitely receiver will never reject any packet. Getting? So to having that control, we have something called flow control mechanism. And in data link layer also we had seen many flow control mechanism like stop and wait, sliding window protocols and all those things. So here also same thing happen. Now we don't have to worry about those things. So what happens is, Now, according to the flow control, when sender wants to send a packet, he has to decide what amount of data I have to send according to the flow control. Right? And how he will decide what amount of data I have to send? What would be the size of the data I have sent at the beginning itself? So that is decided looking at the receiver's buffer. And how sender will came to know what would be the receiver buffer? Yes, there were something called advertising window. See, receiver will keep on advertising his window size. That is called advertising. There is something called advertisement window. Okay. So using this advertisement window, receiver will keep on advertising what his buffer size is to the sender. Okay, using this advertisement window, receiver will keep on advertising to sender what its buffer size is. Okay, so like this, sender will came to know what the receiver buffer size is. Okay, and sender will adjust his buffer size according to that thing. Okay, so let's consider the buffer size of receiver is 16 kb. Okay, means I'm denoting it WR. Means receiver window size is 16 kb, and this is advertised to our sender, and sender also came to know that the receiver size is 16 kb. Okay, so sender will also adjust its buffer size according to it, so it will adjust it as 16 kb. This is how sender will decide how much amount of data he has to send at a time. I'm not telling that he can't send the maximum. See, at a time he can send only 16 kb, maximum of 16 kb. Because see, you have to understand, here in this situation, I'm just talking about one sender and one receiver. But what happens in real world? See, there are a lot of senders. Okay, there are a lot of senders, and they will keep on sending a packet 16 kb 16 kb 16 kb 16 kb, right? That's why I'm telling you that this particular restriction will be there. Now if all this sender will keep on sending this 16 kb, then what will happen? And all this 16 kb is getting into this network, right, at a time. Now there is something called a congestion window. There is a word called congestion window. So what I mean is, when all the sender is dumping the packet 16 kb at a time, even this particular entire network, okay, even it also has that capability of handling all this 16 kb at a time. Are you getting it? So it's not about just knowing the receiver size is enough. Even you should know the size of a network itself, how much packet it can handle at a time. That size also should be known by the sender, because now sender only, see, using a flow control mechanism, sender understood that receiver can handle up to 16 kb, so sender adjusted its window size, right? So that receiver will not reject the packet. Now the problem is, at every sender, this particular for example, at every sender side, the buffer is restricted to 16 kb, and everywhere from all the world 16 kb packet is dumping to the network. Now you should also know how much packet this network can handle at a time, because from everywhere 16 kb 16 kb 16 kb is coming to the network. Now you should also know whether this particular network can handle those many packets at a time, right? So there where the new terminology come into picture is congestion window size. So congestion window size, it is denoted by something called congestion window size. Congestion window, okay. Now its size is denoted by, let's see, WC. Okay, so this is nothing but congestion window size. Okay, congestion window size, it can be denoted like this, or you can call it as congestion window size. Okay, so it is denoted by WC. Okay, otherwise you write like this, you might get confused. Right here, it can be short form, it can be denoted like this, conjection window. Okay, and WC means conjection window size. Okay, now it will be clear, right? So WC means conjection window size, and if I write like this is just a small notation, CWND, that conjection window, right? So I might use in this lecture all this terminology. Okay, so this is just a convention, that's it. So WC means conjection window size, WR means receiver window size, WS means sender window size. Okay, so now somehow you find out that the conjection window, okay, of this entire network is WC. It is WC. Somehow I don't know what is that WC. Okay, somehow I found out that the size of this entire network is WC. What I mean, again I'm telling you, it means that amount of data which this particular network can handle. Network, inside the network, what is that? Router. See, you have to understand one thing. Router is very busy device. Okay, it's never free. It is because it has to compute lot of routing. At every router there is a routing table, right? They have to route the packet, and according to that they have to process it. So router is very busy, and if you keep on, see, from every sender is keep on dumping the packet 16 kb 16 kb, and at a time it can't handle all those 16 kb, then there would be a problem, there would be chaos, right? Then there would be a congestion. This is how the congestion happens, right? So you have to handle this problem. So you have to, for that, what you have to do is you have to find out first what would be the size of the entire network. Okay, what a network can take means what would be the size of the conjection window size. That means at a time how much, what I mean is, if I'm talking about conjection window size, and what I mean is at a time how much amount of data this particular network can take. Okay, according to that, a sender should set his window size. So sender should set his window size. See, all this control can be controlled when the sender, how much amount of data a sender can dump into the network or send to the receiver. If this control is within us, then definitely there would be no congestion or loss of packets. See, if we have a control that how much data a sender can send to a receiver, then definitely receiver will not discard the packet. And definitely if we have a control that how much data sender should dump into the network, then definitely here also network will not reject the packet. So if you give more data, if you dump more data, what a network will network can take, then definitely this entire network will reject the packet. And if you dump if you send the packet with a receiver can handle, then definitely receiver will dump the packet, receiver will discard the packet. Fine. For that you have to have a control on the sender side itself. Are you getting it? Now what we come to know is that every control is at the receiver, at the sender side only. So if he can control the packet, if he can control the packet, how much amount of data he should send to the network and to the receiver, then the problem is solved, right? If he can control what amount of data he had to send to the network and to the receiver, if he set that amount of data in such a way that even the network will accept that data, that amount and that size of packet, and even receiver will accept that size of packet, then definitely the problem is solved, right? Then sender should adjust the data size in such a way that both the parties, both the network and receiver, will accept it and they will never discard the packet. Then this congestion and this rejection of packet, retransmission, all this problem will be solved. So if we have such control, then definitely there would be no problem. So there comes something called congestion control mechanism. That is what a congestion control mechanism does. Congestion control mechanism is nothing. It will ensure that what a sender should set a size of a data. Okay, it will already tell the sender that you just reduce the amount of data this much and send to the network and the receiver. Okay, somehow you reduce this much, network will send to the sender that I can't handle this much amount of data, and receiver will also send that I can handle this much amount of data, you send less than that. So somehow if you handle this both cases, there would be no congestion. Then let's see what would be the sender size then. Okay, so for example, we come to know that our congestion window size means the size of the network is WC and the size of the receiver is WR. Then sender should send minimum of them, minimum of whatever the size is. Then sender will adjust his buffer size according to it. For example, if sender, for example, congestion window size says that that network congestion window size means network says that I can handle up to 1 MB file at a time, and receiver says I can handle up to 10 MB at a time, right? Then what would be the answer? Then what would be the sender window size? Sender window size should be 1 MB. So sender will adjust its buffer size according to the minimum of them. So minimum is 1 MB. So sender will adjust his buffer size of 1 MB. If it is vice versa, if for example, if congestion window says that I can handle up to 1 GB and receiver says that I can handle up to only 10 MB again, okay, then what would be the sender window size? And it would be only 10 MB according to what is the minimum. So this is what the control we got. So according to this, sender will adjust his window size, right? Then most of the problem would be solved. So by this we stop the traffic from the sender side so that our network is safe and our receiver is safe. Okay, and unnecessary of retransmission, discarding packet, all this will not happen. Okay, and all this thing now flow control mechanism is the one who will advertise the. Now you might be thinking that how this thing all happens, right? See the flow control mechanism. I told you there is something called flow control mechanism. So flow control mechanism, they are the one who will advertise using advertisement window. They will tell to the sender what would be the size of the receiver. So flow control mechanism will take care of all those things, right? And there is something called congestion control mechanism. Okay, there is something called congestion control mechanism. It will protect the network itself by letting know what would be the congestion size, and according to the receiver will adjust it. So flow control mechanism will protect the receiver and congestion control mechanism will protect the entire network. Okay, if this, so this is how, and according to that sender will set his buffer size. Fine. Otherwise what happen is sender will keep on dumping the packet to the network, which a network can handle, and it will keep on sending a packet to the receiver, which receiver can handle, and both will crush. Okay, so receiver is protected by flow control mechanism and network is protected by something called congestion control mechanism, and that is what we are going to see. Okay, flow control mechanism we already learned it, right? Now we are going to see about congestion control mechanism. So whatever I explained, I had mentioned here in the notes itself. You can see a flow control, right? So what is a flow control? Sender window is the maximum amount of data the sender is allowed to send based on the receiver's capacity. Exactly what I said. Who controls it? Receiver. Okay, so how receiver controls it? Because through the receiver window, I told you there is something called advertisement window. Receiver will keep on advertising it, okay, using a TCP header. Okay, all this thing in the field, in the TCP header field, there is something called advertisement window. Okay, I will show you 1 minute. See, we can see here there is something called field called window size. So at the receiver side, this window size will be there. Okay, so at the receiver side, the window size may be 16 KB or something. So when any dump packet is any packet would be any temporary packet or any imaginary packet would be any, for example, any small amount of 1 byte is sent to the sender, and sender will look at the, and there would be a pure acknowledgement also you can send. So in that there would be header, right? At least there would be header, and it's a part of a header. So inside the header the size of the receiver will be mentioned. So if you send that packet to the sender, sender can easily find it out that what would be the size of the receiver just looking at the window size. This is how sender will also understand what would be the size of the receiver just looking at the header field of the receivers. Fine. So this is the TCP header. What we are looking at is TCP header because we are at the transport layer. So it uses a TCP protocol. So TCP header has all this field, and in this field one of the field is window size, and this window size at the sender it will be filled with whatever the size of the buffer. Okay, so for example, the receiver had decided 16 KB, that would be the size of my buffer. Then it at Windows there would be window size will be filled with 16 KB. Now this data, for example, I will show here itself. What will happen is there would be a data, right? So sender will send there is a sender and there is a receiver. The receiver will send one pure acknowledgement or a 1 byte data like this. Okay, this is a TCP header. This is any 1 byte data, or he can send even a pure acknowledgement or something, and this data is received by a sender. Now sender will look into this header field, and inside the header field it is already mentioned 16 KB. Like this, sender will understand that what would be the size of the receiver. Okay, so that is what I'm talking about. So this is how this flow control mechanism will work. You don't have to worry about it, right? Now what is the purpose of flow control mechanism? To prevent to protect the receiver from being overloaded, right? So we understood this is how we can protect our receiver. Now to protect our network, we have something called congestion control. So we had learned one thing about congestion window. What is congestion window? Congestion window is the maximum amount of data a sender can transmit based on the current network congestion. Okay, based on the whatever the current network congestion is, that particular congestion window will be adjusted, right? So according, that is the maximum amount of data, right? So that maximum amount of data will be displayed to the, will be advertised to the sender, and sender will adjust according to it, the minimum of congestion window and receiver window. So all this thing we had seen. This is just a note which I made. I just want to show you, right? So whatever we explained previously, that same thing we had written here. Now who controls it? Sender side only, right? So sender will adjust it according to whatever the congestion window is. Fine. So we came to know that using congestion window control mechanism, congestion control mechanism, we can protect this entire network, right? And for that we should know the size of a congestion window. Now my next question is, how you will find out this size of this congestion window? And there is a problem here. If you look closely, see, there are a lot of routers here, right? There are a lot of routers here. What is congestion window size? It's the amount of data what this particular network can handle, right, at a time. Now how you will figure it out? There are so many routers, and so many routers are there on the way. How you will find out what are the capacity of each routers and what is the capacity? See, router also had some few buffers. So how you will find out all the buffers in the router, what is their capacity? There is no central authority who is going to manually calculate all those things, and no algorithm also possible. So nowhere you can find the, so the biggest problem is that nowhere you can find the size of a congestion window. Then there is something called, see, then all this mechanism what we are talking about, all this fails, right? See, if you are unable to find the congestion window, then this congestion control mechanism will not work. Then whatever we said, all this fails, right? Then there should be something so that somehow you can find out congestion window. So then there is a small rule. See, if you can't predict something, okay, or if you can't calculate something, then start from the minimum. Okay, so what will happen is that this congestion window, it will start from the minimum size, the most minimum size, whatever it is, it will start from that and it will send it to the sender. So that is how the thing is. If you can't predict something, start from the very minimum. Okay, so we will see that part. So with that respect, we have something called additive increase and multiplicative decrease algorithm in congestion control mechanism. Okay, so congestion control mechanism, you make use of this particular algorithm. Okay, that is called AMD algorithm. Okay, so the main reason we need is, see, we can't predict congestion control. We can't predict congestion window size, right? So if you can't predict it, start from minimum. That is what additive increase says. So AMD algorithm is, we need AMD algorithm because we cannot precisely know the network capacity or bandwidth or congestion window size needed for the smooth data flow ahead of time. So for that we need this algorithm. Okay, so okay, now there are these are the theory about the AMD algorithm. Now before getting into this AMD algorithm, I will explain you with an example, then I will read this particular notes. Okay, then you will understand it properly. So I will explain it with example, then we will come to this particular notes. So for understanding this AMD algorithm, you have to assume few things. Okay, then only this AMD algorithm will work, otherwise it will not work. One thing is, initially we assume that our congestion window, okay, I told you na, if you can't predict it, then assign some minimal amount. That is, I am predicting it, I am assuming it, my congestion window is 1 kb. Okay, this is the smallest possible because there would be some space left in the computer, in the network. So I am assuming the lowest one, that is 1 kb. And whenever I talk about whenever I talk about kb, okay, convert 1 kb equal to 1 MSS. Means here 1 kb equal to 1 MSS. Assume all this part. Okay, so whenever I talk about 1 kb, you convert into 1 MSS. 1 MSS means maximum segment size. I think I explained all this thing back then also. So what does it mean is, what is segment? When you take this particular data, there would be something called data, right? And plus header, TCP header. So together they become a segment. Then what is the size of this one segment? That is what I am talking about. Okay, the size of this one segment right now maybe 1 kb. So that is what I am talking about. The 1 MSS means size of one segment. Okay, so that is how you maximum segment possible. So maximum segment size. So whatever the maximum segment you are sending to the particular network. So that is how you can understand this part. Okay, so whenever I talk about 1 kb, you consider it 1 MSS. Okay, fine. And next assumption is receiver window size. Okay, I am fixing it. I am taking receiver window size as 16 kb. Okay, now when the receiver window size is 16 kb, this particular 16 kb will be advertised to a sender, right? So receiver will advertise his window size to a sender. Then what will happen? Then sender will also set his buffer size as 16 kb. That is what happens. Okay, so receiver will advertise 16 kb, then sender will also set it as 16 kb. Okay, now what we are going to assume here is, we are going to fix this 16 kb throughout. Okay, throughout our example we are going to fix this receiver window size as 16 kb. See, generally what happens is, see, for example, there is a receiver right? There is a receiver. Now, for example, the receiver had advertised that its size of its entire buffer is 16 KB. Fine. Now, then sender will also set it will advertise it, and sender will also set it as 16 KB. Right. Now, sender will send some amount of data. For example, that amount of data is 10 KB. Sender will send this packet 10 KB data, okay, to the receiver. Right. Now in the buffer there is 16 KB, so 10 KB is full, right? Now the remaining is 6 KB. Remaining is 6 KB. Right. This is full. This part is full. 10 KB. Now next time when receiver will advertise his window size, then what would be the size? It will advertise 6 KB. It will advertise 6 KB. Okay, not 16 KB, because now the actual size of the buffer is 6 KB, so it will advertise 6 KB. Then sender will also adjust its size according to it. Now it will adjust its sender size as 6 KB, not 16 KB. Okay, so there is a contraction now. So this is a dynamic window. It will contract, okay, expand according to the situation. Okay, so it will increase and decrease according to the situation. So now sender will adjust his size according to the receiver's advertisement window. So it is 6 KB now. Now what I am telling is, here for this algorithm, for additive inverse, for this additive increase, multiplicatory decrease algorithm, AMD algorithm, I will always assume the receiver will always have 16 KB backup buffer. It will always have 16 KB in its buffer as a buffer size. I'm not going to, this is the general scenario, but I will not assume this thing. I will always assume the receiver has 16 KB always left in its buffer size. Okay, with that assumption, I'm going to explain this example. Are you getting it? So we fix this size as 16 KB. So every time receiver will advertise only 16 KB, 16 KB. It will not this increase, decrease, all this we are eliminating it. Okay, with this assumption, we will move forward with our example. I hope you understood what I mean. Let's see one example. You will understand it properly. Now in this algorithm, what will happen is there is a sender and receiver. Okay. Now sender at the beginning, he will send one MSS. One MSS means one segment. Okay, I told you now, one MSS means each of 1 KB, right? So 1 KB is equivalent to 1 MSS. Consider like this. Okay, so he will send one MSS, means one segment. Okay, then for that one MSS, he will receive acknowledgement. Okay, so again I am telling you, convert 1 KB, if KB is written, convert 1 KB into 1 MSS. That's it. Problem solved. 1 KB equal to 1 MSS. That's it. Okay, so first time you will send one segment and acknowledgement is received. And second time, when the acknowledgement is received, second time you will send two segments, each of 1 MSS, two segments. And for both the segments, you will receive the acknowledgement. Right? And when you receive the acknowledgement, then second time you will send 4 segments. 1, 2, 3, 4. And for each segment, you will receive the acknowledgement. 1, 2, 3, 4. Okay, so here I am, just for simplicity, I am making it only 1. Okay, but you understand there are 4 segments. Okay, so after receiving an acknowledgement for 2 segments, you will send next time 4 segments. And for that also you will receive the acknowledgement. And after receiving the acknowledgement, then you will send 8 segments. 1, 2, 3, 4, 5, 6, 7, 8, like this 8 segment. And for each segment you will receive the acknowledgement. Okay, so this is how this algorithm will start. Okay, so can you observe all those things? So the thing is, see, for simplicity I am putting only one line. Okay, it's 8 segments. Now if you see, look closely, there is one segment, after that 2 segments, after that 4 segments, after that 8 segments. So you can see 1 means what? 1 means you can write like 1 means what? See, 1 means 2 raised to power 0, 2 means 2 raised to power 1, 4 means 2 raised to power 2, 8 means 2 raised to power 3. So we can say that this particular growth is exponential growth, right? This is an exponential growth, right? So we understood what it, how this particular example works. Now we will assume the same example, okay, with these parameters. Okay, I will assume some parameters according to these. We again revisit this example, okay, because I want to clarify some few concepts again. So what we will assume here is advertisement window is 8 KB. What does it mean? That receiver will advertise that it has a buffer size of 8 KB. Let's take instead of 8 KB, let's take 16 KB. Okay, then it would be easy to solve. Okay, let's take 16 KB. Okay, then one point will be clear. Okay, instead of 8 KB, we will take 16 KB. Yeah, fine. Now, if advertisement window is 16 KB, then what does it mean? The receiver is advertising that its window size is always 16 KB, and I'm going to fix it. Always receiver will advertise it as 16 KB. That is what we assumed it. And receiver, I will assume as, then what would be the receiver size? Definitely it would be 16 KB, right? Now, what would be the congestion window size? So congestion window size, I told you, we can't predict congestion window size, right? So we will assume the minimum. That is how we have done this part also, right? So we will assume it as minimum, which is 1 KB, right? Now, according to this, what would be the sender window size? It would be minimum of congestion window size and receiver window size, and minimum that is 1 KB, and okay, here it would be 16 KB. So congestion window size is 1 KB, receiver window size is 16 KB. Then what would be the minimum? 1 KB. So we got sender window size as 1 KB. Fine. Now there comes a MSS. MSS is 1 KB. This is also be assumed that as 1 KB. What is MSS? MSS is the maximum amount of data a TCP can send at a time, or a sender can send at a time, maximum amount of data. Okay, that each segment what you are sending now, its maximum amount should be 1 KB. Okay, if you are getting confused, I had written the definition also here. See, the MSS is maximum segment size is the maximum data TCP can send in one segment. Okay, if you take one segment, okay, that what would be that size of that segment? Okay, that is what the maximum data, that is what MSS is, because without causing a fragmentation. So that you should avoid fragmentation. So you might be thinking, what is the difference between this kind of sender window size and MSS? Okay, if you already have sender window size, why we need MSS and all those things? See, okay, let's take one example here. You will understand the clear difference here. For example, sender window size is 10 KB. Okay, and MSS I set as 1 KB. Okay, so TCP I set the MSS as 1 KB and sender window size as 10 KB. Now, what is the meaning of this? Sender says that I have a buffer size of 10 KB, and MSS says that yes, okay, you have a buffer size of 1 KB, it's okay, but you can't directly send a 10 KB at a time to the network. Okay, what MSS says, you send 10 KB, but each segment should be of 1 KB. That is what MSS says. You send 10 KB, but each segment should be of 1 KB. Okay, like this you send 10 segments, then that total would be 10 KB. You can't send 10 KB, that total 10 KB at a time to the receiver. Why we are doing it? Because, see, remember, in between I told you there would be something called routers and all those things, right? Okay, when this particular packet, if a sender sends this entire 10 KB at a time, okay, then what will happen is, see, 10 kb, then what router will see, router will also calculate how much other network, router may be connected to some other network. Then if the network size is not able to handle 10 kb file, okay, then router will cut these pieces, this particular data into pieces, okay, according to the size of the network, what the other sides of the network can handle. For example, this receiver is another size and its network can handle only 1 kb file at a time. Just consider like this. Then what a router will do, router itself will cut these pieces into 1 kb 1 kb each, like this, 10 pieces. He will make 10 pieces, 10 segments. Then see, so when router does this work, now what a sender has to do initially, then there is an overhead. Because of this, lot of processes, router is not a free device, okay, router has lot of work, it is never free, it's never idle. So all this work what a router is doing now, this cutting into pieces, then at the end these pieces will go one by one and it will reassemble in the receiver. All these are overhead, all these are overhead in network. We have to avoid it, we have to completely avoid it, okay. All this is called fragmentation, this part is called fragmentation. Anyway, you don't have to worry about this fragmentation, okay, don't worry about fragmentation part, okay. Now just so that you can understand what is MSS, that's why I explain all this thing, okay. So if a router will calculate the size of the network, other sides of the network, and we will find out that it can handle at a time 1 kb only, so it will not directly send this 10 kb to this particular network, it will cut those per data into 1 kb and like this 10 segment. And when router does this thing, it's all overhead, it takes lot of time because router has lot of work to do. It has to compute the routing table and it find out the route, what is the shortest route, and all this work is done by router. And at that time you give this work to the router for cutting down the data into pieces. This is all overhead, it's a lot of workload, this workload will increase, right? So you have to avoid all these things, okay. So what they are suggesting, when you set MSS as 1 kb, instead of sending 10 kb at a time, you will send 1 kb, then router will directly forward that 1 kb to the other network, it doesn't have to do all this fragmentation. That's why in the initial phase only we will set MSS as 1 kb, so that even your sender size is 10 kb, you will not directly send 10 kb to the router, you will send 1 kb each of 1 segment, each of 1 kb, like this 10 segment you will send, and you will able to send 10 kb, okay. So you understood what is MSS, that is why we are setting at MSS. Don't worry about this fragmentation part, it's okay, right? That is what we assumed here, MSS as 1 kb, fine. And I also told you one thing, that let 1 kb equal to 1 MSS, right? If you consider like this, then this 16 kb equal to 16 MSS, right? Convert every kb equal to MSS, 16 MSS, right? When you solve the problem now, convert like this, this become 1 MSS, right? This also become 1 MSS, this become 1 MSS, right? After converting every kb into MSS, then you try to solve it. Now you will understand it properly, okay. Now again coming back to this particular example. Now I told you conjunction window size is 1 kb, that means your additive. Now the algorithm, I'm talking about AMD algorithm again, okay. So AMD algorithm, now with this particular parameter, our AMD algorithm, what it will does, that's why we have taken one segment at the beginning. So it will start with 1 MSS, okay. It will start with 1 MSS because that is what our sender window size had agreed upon, okay. So it will start with 1 MSS, okay. And even our MSS means what is the maximum segment size, that is also 1 kb, right? Now second time it will gradually increase, okay. Then second time it will send 1 MSS and second MSS, means 2 segment it will send, okay. So sender is a dynamic, sender buffer size is a dynamic buffer, okay. It can increase and decrease at a time. So first time it will send only 1 segment, Okay, then second time sender got the acknowledgement, sender will again send two segment. Okay, each of 1 MSS. 1 MSS because we are agreed upon 1 MSS. Then third time when the sender receive the acknowledgement, then third time sender will increase his buffer size. Okay, buffer size, so that it can send up to 4 segments, each of 1 segment. Like this it will send 4 segments, right? So each will be of 1 MSS, means 1 KB, right? So when all the segments what he is sending now, if he receive the acknowledgement, then sender will send 8 segment. It will increase the buffer size. Then it will send 8 segment. That means 8 segment, 1 2 3 4 5 6 7 8, and each segment will be of 1 KB. That means like this 8 segment it will send, right? Then it will receive all the acknowledgement, right? Now what is the thing? Now what will happen? Now according to the additive inverse multiplicative, means AMD algorithm, what AMD algorithm does is, okay, now what will happen next time when you receive the acknowledgement, as our receiver size is up to 16 KB, right? So it can receive up to 16 segments at maximum, right? So after the acknowledgement received, next time you will send 16 segments at a time. The sender will send 16 segments at a time. Okay, each segment of 1 MSS, 1 KB. And if for all the 16 MSS, when it receives an acknowledgement, okay, so it will send 16 segments here. Now after receiving acknowledgement, then we can clearly see we had reached the full potential of a receiver. Now we had reached the full potential of a receiver, right? Now when we reach full potential of receiver, then what AMD will do, that we have to see, right? We can see 16 segment, that is the full potential of the receiver. Okay, so now after that AMD will do something, okay, that we are going to see, right? Now see here, sender is sending at full capacity, right? Now sender has reached to his full capacity. Then after this, sender will keep on sending 16 MSS. Keep on sending 16 MSS. Like this, it will keep on sending 16 MSS. Right? So this will happen after reaching to the full capacity. Sender will keep on sending 16 MSS, 16 MSS like this. Now the thing is, all the senders, see, it's not about one sender. All the senders are at full capacity, and 16, you keep on sending 16 MSS, 16 MSS, 16 MSS at full capacity. Now again there would be a problem of congestion, because every sender is in full capacity and they are sending 60 MSS at a time to the network, right? Then there is something, see, this AMD it will do something smarter. It has one phase called congestion avoidance phase. What does it mean? That even before congestion will happen, it can avoid it. So it will enter into something called congestion avoidance phase. So it will not directly, see here what I'm telling you, that after 8 MSS it will directly get into 16 MSS, because after 2 raised to power 3 something, what is the answer? After 2 raised to power 3 it is 2 raised to power 4, which is 16, right? So it will start sending 16 segment. But this will not happen exactly. It has something called congestion avoidance phase. AMD has a congestion avoidance phase. So instead of sending these 16 segments, see, instead of sending this 16 segment, AMD will do something smarter. At initially only, AMD will calculate something called threshold. What is threshold? It is receiver window size divided by 2. What is receiver window size? It is 16 MSS, right? 16 MSS divided by 2, which is nothing but what? How much? It would be 8 MSS. So this it will calculate at the beginning itself. It will be calculated at the beginning itself, right? Now instead of sending this 16 MSS, AMD will instead of sending this AMD 16 MSS, AMD will enter into something called congestion avoidance phase. Okay, it will enter into congestion avoidance phase. Congestion. So AMD will enter into something called congestion avoidance phase. So what I mean is, see, sender will send first one segment, okay, then two segments, four segments, right, then 8 segments, and after that it will reach to the threshold, right, it will reach to the threshold, particular threshold. Then after that, instead of directly sending 16 segments, it will enter into congestion avoidance phase. Congestion avoidance phase is nothing that before even some congestion happen, it will avoid it, right? So what happens in congestion avoidance phase, then instead of sending a 16 segments directly, it, our AMD will do something something smart. It will send linear, it will grow linearly. After that it will send 9 segments, then it will send 10 segments, then 11, then 12, then 13, then 14, then 15, then it will send 60. Okay, like this linear growth. This is called linear growth. Linear growth. This was exponential growth, right? 1, 2, 4, 8. Then after congestion avoidance, it will grow linearly, right? So what will happen here? See, after 16, what happened? 16 is the maximum receiver size, right? And after growing here, after sending 16, it will keep on, after reaching to the maximum potential of reset, after this it will keep on sending 16, 16, 16 like this. It will maintain the sender size. Okay, so this is how this AMD will work. Fine. So here also it will, after 9 it will send, after 8 it will send 9 MSS, right? For all the MSS it will receive the acknowledgement, and after that it will send 10 MSS, right? For all the 10 MSS it will reach the acknowledgement, right? Then it will send 11 MSS, right? And for all the 11 MSS it will reach the acknowledgement, right? Like this it will send for 12 MSS, then for all that 12 MSS will receive acknowledgement, for 13 MSS, right? For all the 13 MSS it will reach the acknowledgement. So you can see after 13, 14, then it will send for 15 MSS, and after that it will reach to its maximum capacity, that is 16 MSS, and after that it will slowly grow 16 MSS. Then it will fix that particular sender size 16 MSS, 16 MSS, keep on sending 16 MSS, 16 MSS throughout. Okay, so after this 8 MSS it will linearly grow 9, 10, 11, 12, then 13, then 14 MSS, then 15 MSS, then it will hit the maximum capacity, that is 16 MSS. Then after that it will maintain that sender size 16 MSS, 16 MSS like this. Okay, this is what AMD algorithm works. This is how AMD algorithm works. So when it reaches to certain threshold, okay, the threshold is calculated by WR divided by 2, receiver window size divided by 2, then it will grow linearly. So this phase is called congestion avoidance phase. So instead of directly sending to a 16 segment, it will enter into congestion avoidance phase. Okay, so this is how our particular AMD algorithm works. So in this, if I ask you what was after so assume that there is one question that after how many RTTs can we reach to the maximum sender size? Sender size means how much after how much RTT means round trip time, that we can reach to the full capacity of the window, sender window size. So how can you calculate it? See, this is one RTT. You can see this entire thing is one RTT. So this is one RTT. This is second RTT. Entire thing. Okay, this is third RTT. So like this, first RTT, second RTT, third RTT. Okay, fourth RTT we reach to 8 MSS, which is threshold. Fifth RTT, 6, 7, then 8, then 9, then 10, then 11. Okay, at 11th RTT we at 11th RTT we had sent 15 MSS. After 11th RTT we reached to the 16 MSS. So answer is 11 RTT. So our answer is after 11th RTT we reach to the maximum sender window size. Okay, so after 11th RTT we reach to the maximum window size, which is 16 MSS. Right, so you see, you can do this process in a simple way also. You don't have to draw all those diagram. What we can do is, see, what was the, we have to send maximum 16 MSS, right? That is our sender window size maximum. So according to AMD process, what we do is, we will start with first we will start with slow start phase. That is called, see, this phase is called, this particular phase na, exponential growth, that is one name is called, that is called slow start phase. Slow start phase. Okay, and slow start phase is not actually slow, it is exponential growth. And that second phase is called congestion avoidance phase, where we grow linearly. Here we grow exponentially, and here we grow linearly. So at first there would be a slow start phase, right? So we will start with 1 MSS, then 2, then 4, then 8. Now we reach to the certain threshold, which we already calculated, that is 8 MSS, right? Then after reaching to that certain threshold, what we will do? We will grow linearly, that is 9, then 10, then 11, then 12, then 13, then 14, then 15. Then after that you reach to the 16. That's your maximum capability of the sender, okay, of the receiver. Then receiver will keep on sending 16 16 like this. Okay, 16. So it will keep on sending 16 16 like this. So now if you want to calculate the RTT, then it's very easy. So RTT is nothing, see, after this one, this would be one RTT, right? You can see after this is one RTT, right? So you start from here. One had already sent, then you will receive, one is sent, then after that you will receive acknowledgement, then that is RTT. Then after that 2 is sent and you will receive acknowledgement, so second RTT, right? Then third RTT, then fourth, then fifth, then sixth, then seventh, then 8, then 9, then 10, then 11. Okay, after 11th RTT you reach to the maximum potential of the window. Okay, so you can even see, this is first RTT, this is first RTT, then second, then third, then fourth, then fifth, then sixth, then seven, then 8, then 9, then 10, then 11. After 11th RTT you reach to the maximum capability. This is maximum. Okay, so answer is 11 RTT. Okay, so why I started from here, see, why I started this line from here is because first you will send one, right, one segment, and after sending you will reach acknowledgement, then this particular RTT will be considered. Then after one RTT is complete, right? So that's why it started from right hand side. After you will send 2 segment, and after you getting acknowledgement, one entire RTT is full, right? So that's why I written here. So this is one RTT, then second, then third. See, don't start from here, then it will be wrong. Okay, even before starting only, before transmission only, you got the acknowledgement. That is the meaning of you when you start from here. Okay, so be aware of all this thing. Okay, fine. See, if I ask one more question, Okay, instead of RTT, if I ask you after how many transmission we will reach to the maximum window size, then this was RTT, right? So don't count this. Now transmission means this part. This is one transmission, second transmission, third transmission, fourth, fifth, sixth, seventh, eighth transmission, ninth transmission, 10th, 11th. This also same answer, but the way we think is different. Okay, so this is RTT and this was transmissions. Okay, so count the segments inside it. Okay, so don't forget, this is just a so that you don't confuse. If such question comes, if RTT comes, then solve like this. Transmission comes, then calculate inside whatever the segment we are. Then this also after 11th transmission, same answer here we got after 11th transmission. Fine. Now if I ask you one question, that after 8th transmission, what is the size of the window, center window size? Then how can you calculate after 8th transmission, 8th? So one transmission, then second transmission, third, fourth, fifth, sixth, seventh, eighth. After 8th transmission, what is the size of the window? That will be 13th. So answer will 13. Okay, so 13 MSS, that would be the answer, 13 MSS. So be careful of such questions. Okay.